There are these animals that came from off-world. These are pariahs. NASA, notable for its basic divulgences, has truly uncovered that this new planet isn't just charming, considering the truth of its size and region, but also because it shows lights that appear to be fake. Are we, for all intents and purposes, uncovering insider truths that could change our perspective on the universe? Might this disclosure, sooner or later, mean there is life on different planets? Go with us as we see NASA's charming exposures and uncover the truth concerning these dumbfounding lights. In 2007, NASA launched the Dawn spacecraft with a mission to explore the most charming objects in our nearby planetary system. Dawn was equipped with 3 ion engines, allowing it to undertake an exceptional trip. Dawn's journey began with a 14-month assessment of Vesta, the second-largest asteroid in the belt. During this time, Dawn sent back detailed pictures and data revealing Vesta's confusing surface and different land features. After completing its primary mission at Vesta, Dawn set out on the second and possibly most charming part of its endeavor, a close evaluation of the dwarf planet Ceres. Using its ion engines, Dawn was able to leave Vesta's orbit and head towards Ceres, an achievement that conventional chemical propulsion would have found challenging. These engines, providing a continuous gentle push, enabled Dawn to travel vast distances efficiently and enter a stable orbit around Ceres. Originally discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt between Mars and Jupiter. For many years, it was considered the smallest dwarf planet in our solar system until its renaming in 2006. With a diameter of around 950 kilometers, Ceres is the largest and most massive body in the asteroid belt, and one of the most intriguing due to its remarkable characteristics. As Dawn approached Ceres, scientists eagerly awaited the first detailed photographs of this peculiar world. They saw bright spots scattered across its surface, most strikingly in a large crater now known as the Acator Crater. These bright spots sparked brief interest and speculations among mainstream scientists. Before Dawn's mission, the best image we had of Ceres was a blurry, low-resolution photograph taken by the Hubble Space Telescope. Researchers had little knowledge of this dwarf planet, and the opportunity to finally get a close-up view was exciting. What secrets would Ceres reveal? What new discoveries awaited the mission? Dawn promised to improve our understanding of the solar system's formation and the role of water in shaping planetary bodies. The bright spots on Ceres were unlike anything seen on other asteroids. They appeared to be made of highly reflective material, possibly salts left behind by sublimated water. This led to the possibility of cryovolcanism on Ceres, a process in which volcanoes erupt with water or briny liquids instead of molten rock. But what exactly are these puzzling lights, and what do they reveal about Ceres? Could they be proof of ongoing geological activity, or something even more extraordinary? Ceres stands apart from other celestial bodies in the asteroid belt due to its size, mass, unique composition, and potential for water and ice. Unlike most rocky asteroids, Ceres has a composition more like a comet, suggesting it holds many more secrets about the early solar system than we had previously imagined. After 2 years on its journey, the Dawn spacecraft finally began its approach to Ceres in early 2015. This moment marked a significant achievement in the mission, as Dawn was able to deliver humanity's first close-up views of the largest object in the asteroid belt. As Dawn drew closer, the pictures of Ceres became increasingly detailed, offering glimpses of a world previously shrouded in mystery. The first images revealed a surface dotted with craters, indicative of a long history of impacts. However, it wasn't just the craters that caught the attention of scientists and space enthusiasts alike. Among these features were odd bright spots that stood out sharply against the darker, rough terrain. As the images continued to improve in resolution, researchers speculated about the nature of these bright spots. Were they ice patches reflecting sunlight, or could they be something far more unusual? Speculations range from mineral deposits to potential signs of cryovolcanic activity. Closer inspection revealed that the brightest spot was not a single entity, but rather possibly a combination of several distinct regions. This discovery only deepened the mystery. The theory that these were deposits of salts left by sublimating water gained momentum. This would suggest that Ceres had, or still has, some form of geological activity capable of moving water or briny liquids to the surface, where they rapidly evaporate, leaving behind bright reflective deposits. These discoveries challenge existing ideas about Ceres, presenting it as a more complex and dynamic world than previously thought. The presence of such features raised the possibility of subsurface water or briny pockets, which could have profound implications for our understanding of the potential for life in our solar system. But what makes Ceres special compared to other planets? Ceres is a fascinating world, often described as a cold planet with a harsh yet fragile surface. Unlike most asteroids in the belt, which are made primarily of rock and metals, Ceres stands out due to its unique composition. Its surface is a mix of water, ice, and hydrated minerals, including clays and carbonates, which gives it a much less dense structure compared to its neighbors. This structure suggests that Ceres has a significant amount of water. The surface layer is rough but permeable, with ice and other volatiles trapped within. This cold characteristic is more suggestive of a comet than a typical asteroid, indicating a history that may have involved a combination of rocky and icy materials. Digging deeper beneath its surface, Ceres reveals even more intriguing aspects of its composition. The dwarf planet is believed to have a differentiated interior, consisting of a slushy mantle and a core. The mantle is thought to be rich in water ice, making up about half of Ceres' total volume. This mantle, possibly a mixture of rock and salty water, surrounds a core that may be made of denser material, possibly silicates. The presence of so much water ice suggests that Ceres may have once held liquid water, especially if its core was heated by radioactive decay early in its history. This internal structure sets Ceres apart from its asteroid neighbors and also raises interesting questions about its potential for geological activity and the role of water in its evolution. However, that's not all. The discovery of ammonia clays on Ceres suggests that the dwarf planet may have formed in the colder outer regions of the solar system before migrating inward. The presence of ammonia lowers the freezing point of water, supporting the possibility of subsurface brines. These insights into Ceres' composition and history not only enhance our understanding of this captivating dwarf planet, but also provide important clues about the processes that govern the formation and evolution of icy bodies throughout the solar system. Cryovolcanism is a fascinating and somewhat unusual geological process, especially when compared to the more familiar volcanic activity we see on Earth. Unlike traditional volcanoes that erupt molten rock, cryovolcanoes, also known as ice volcanoes, emit volatiles such as water, ammonia, or methane. These substances can exist as liquids or gases in the freezing conditions where cryovolcanoes are found. On Ceres, cryovolcanoes operate by allowing water mixed with dissolved salts to reach the surface. When this briny water interacts with the vacuum of space, it quickly evaporates, changing directly from a solid or liquid state to a gas, leaving behind bright reflective salt deposits. These salt deposits form the strange bright spots observed on Ceres' surface. The most famous of these bright spots is located in a crater known as a crater, specifically in a region referred to as Spot 5. This area has drawn significant attention due to its high reflectivity and unusual fogs observed by the Dawn spacecraft. These fogs are believed to be caused by the sublimation of water, suggesting that cryovolcanic activity may still be ongoing or may have occurred relatively recently. Moreover, Ceres has several other bright spots, each with its own unique characteristics. These spots are not confined to a single area, but are spread across the dwarf planet's surface, indicating that cryovolcanism may be a widespread phenomenon on Ceres. The presence of these bright spots underscores Ceres' extraordinary nature and raises important questions about the potential for life in our solar system. The dynamic and evolving nature of Ceres challenges previous assumptions that it was a geologically dead world. As the Dawn spacecraft provided more detailed images of Ceres, a wealth of surface features began to emerge. The outer layer of Ceres is marked with various craters, each telling a story of the dwarf planet's history. Some craters are relatively shallow and eroded, showing an old surface that has been subjected to numerous impacts over billions of years. Others are better preserved, with sharp edges and deep bowls, indicating more recent impacts. Interestingly, the number of craters on Ceres is less than initially expected, suggesting that geological processes might be rejuvenating the planet and erasing evidence of older impacts. One theory is that Ceres' icy crust undergoes a kind of cryovolcanic resurfacing, where subsurface materials occasionally well up and cover older features. This ongoing geological activity suggests that Ceres may be a far more active world than we once thought, with the potential to uncover even more secrets as future missions continue to explore this enigmatic dwarf planet. This ongoing geological activity on Ceres suggests a more dynamic planet than previously believed. The resurfacing process, possibly driven by cryovolcanism, indicates that Ceres may have the capacity for internal heat, potentially sustaining subsurface liquid water. This raises the intriguing possibility of a habitable environment, offering new insights into the potential for life beyond Earth. As scientists continue to study Ceres, its evolving surface and distinctive characteristics make it a prime candidate for further exploration, with each discovery bringing us closer to understanding the mysterious processes shaping our solar system's icy bodies.